Chapter 14, Principles of Pollution Control. Pollution generally refers to excess outputs by society into the environment. Pollution is also a matter of cycling and energy flow, meaning that pollution can be the disruption of a cycle where accumulation occurs outside the natural reservoir. Pollution is an acceleration of a natural process. For example, volcanoes emit gases that cause acid rain and greenhouse effects. But then society can accelerate these processes we see in nature. Pollution is also stepwise, meaning waste is accumulated at each step of a process or activity. This waste then ends up polluting either the lithosphere, hydrosphere, or atmosphere. In the end, pollution equals the population times consumption and the waste streams that provides. Society's pollution emissions overwhelm the absorption ability of our natural ecosystems. The quantity of waste produced is vast in industrial society. The quality of our waste accelerates pollution because it contains so many new substances that are unknown in nature. Increasingly, engineers are asked to use life cycle analysis or cradle-to-grave practices, where all materials in a product have designated recycling or disposal routes that meet government standards. Pollution is as old as the Earth. Volcanic activity has devastated the biosphere in the past, and the first written records indicate that earlier civilizations also had pollution problems. For example, drinking water was a perennial problem in early societies. Then later, coal burning caused air to be unbreathable in towns during the Middle Ages. The scale of human-caused pollution is now much greater than it has ever been. So how do we control pollution? Well, controlling pollution requires far more than passing laws to stop toxic emissions. There are many myths about pollution control that have led to costly political and economic decisions. Those myths include the purity of nature. The myth of purity of nature, for example, when we talk about clean air and water, we have to remember that the chemicals exist in the world, and that when something is polluted, it often means that a substance is present in low quantities that do damage. But in general, many chemicals exist and do no damage. So there is no pure nature. There's also a myth of zero pollution. Society cannot exist without creating waste, especially with the number of people on the planet. So human activity creates waste, and cost can be prohibited to dealing with that waste. Most environments can be cleaned up, but nothing can be cleaned completely. In addition, toxicity is very much related to concentration, so cleanup has to be both cost-effective and to a point of low impact. This is okay because benefits decrease exponentially when concentrations get very low. Most environmental standards are compared to background in nature. For example, background mercury in Maine rivers is about 2 nanograms per liter. This is well below the standards for fresh waterways and even drinking water by the EPA and other established EPA and also under the established Clean Water Act. Trying to clean up this level of mercury in rivers in Maine would be cost prohibitive and have little benefit. Finally, there's a myth of zero risk. All activity has risk associated with it. The trick is to assess the risk of pollutants and then use that information to make decisions about cleanup and prevention. So how much pollution is sensible? Usually, when we talk about this kind of idea, we want to protect the most vulnerable in society. Often risk in society is pushed onto the disenfranchised and the poor. These people often get the worst health care, worst jobs, and housing in the worst areas with the highest environmental risks. So if we can look at these areas and figure out what risk is accessible, then we can determine what risk to set levels at. Pollution control has yielded benefits for human health and environment that are measurable, but it also comes at a cost. So how do we balance these competing interests? This graph shows the increased costs associated with pollution control over the last 35 years. Many would argue it's too much, but many would also argue that without controls, then the environment would look like industrial Ghana, Indonesia, Ukraine, or Russia. Increasing costs and changes to the global economy is one reason that sustainability has gradually replaced environmentalism in America. Sustainability takes into account the economic versus the legal implications of environmental impacts. This has led to an increased use of cost-benefit analysis of pollution control measures. Historically, pollution misinformation or myths influenced policy, which led to the idea of rights-based and technology-based approaches to control. Rights-based control assumes everyone has the right to the highest pollution control possible and sets standards accordingly. That's often driven by the idea that pollution can be completely eliminated, which is a myth, and that we should eliminate pollution to the best of our technological ability. As society shifted from environmentalism to sustainability, these types of ideas have changed. So if we use the technological-based approaches to set standards, then every time the technology changes, our standards would change. When we use economic factors, or we factor in economic factors, then when we use technology and legal factors only, we have very stringent and sometimes very costly environmental decisions that are being made. Both strive for zero pollution and zero risk, which are unattainable. With the advent of sustainability practices, cost-benefit analysis came into the picture. As pollution is removed during cost-benefit analysis, the relative benefits of further pollution control decrease and the economic costs of control increase. Ideally, the intersection of these two lines is where benefit-cost ratio is optimized. There are, however, drawbacks to this type of analysis. Benefit-cost analysis results can be very misleading or worthless if some benefits or costs are omitted or inaccurately estimated. These types of costs have a lot of political pressure put on them, so actually understanding whether you have a true cost or a true benefit analysis is very important. This is very likely when dealing with environmental problems because it's very difficult to estimate the value of many environmental resources, and also the contingent value of many resources, and can be very political. The contingent valuation method, or CVM, attempts to objectively measure the dollar value of changes in the environmental quality. CVM determines environmental costs through surveys. In other words, what would you be willing to pay to lower your risk for something? For example, how much would each person in a neighborhood be willing to pay per month to lower your risk for increased air pollution from a new power plant, or to build a better water treatment plant? These types of surveys actually bring in hard numbers with what people are willing to pay. These values also are troublesome because they're often subjective to current cultural value and fluctuate depending on the political climate. But this is a new method to do some cost-benefit analysis. Just like we talked about in the beginning of class, managing throughput is a good way to think about pollution reduction. Pollution reduction attempts have traditionally emphasized output management, or trying to remediate things once they are polluted. Pollution can be reduced much more cheaply by greater application of input reduction methods. Enhancing output control with increased efficiency or reduction methods can result in more pollution removed for less money. In other words, managing your input and lowering your output is cheaper than trying to fix things once they're already out in the environment. Output control rarely promotes conservation and is usually much more expensive than input reduction methods. Waste removed by filtering or scrubbing requires costly treatment and increases the problem of disposing the waste in landfills or incinerators. These are the types of arguments you hear about when people start talking about regulating carbon from energy plants. Remediation after pollution is left through an output attempts to counteract some of the effects of pollution after it's been released, whereas restoration seeks to return the environment to its former state. These are words we've used before when we talked about conservation. However, these things are very expensive and hard to do after pollution's already occurred. Prevention is much more inexpensive. Whether it's an input or an output control, implementing the controls is a very difficult step because it usually entails monetary costs and changes in behavior. And these are costs that do not lead to direct business benefits like profits. So they're just costs, and they're fought usually very hard by the business community. 3 basic methods can promote change in human activities. They include persuasion, regulation, and incentive. Input reduction controls require a larger scale approach than output controls because it's more of a cultural shift and a change in the business climate or the population climate. There are some legal aspects of pollution control. Regulation by laws is most useful where polluters are few in number and the population can be easily monitored. Legal regulation of industrial chemicals and pollutants began in the first half of the 20th century and became concentrated with OSHA, the Clean Water Act, the Clean Water, Air, Drinking Water, and Superfund legislation in the 1970s. Most of this legislation was in response to the public outcry of highly polluted water and air in the country. These types of laws work well on point source polluters, such as large industries where waste streams are known and can be monitored. They're less efficient on non-source point pollution, such as excess use of fertilizers by homeowners, herbicides and insecticides from agricultural lands, and residential areas. They're also difficult to monitor things like oil, grease, and toxic chemicals from urban runoff and energy production, sediment from improperly managed construction sites, crops, and forest lands, salt from irrigation practices and acid drainage from abandoned mines, bacteria and nutrients from livestock, pet wastes, and faulty septic systems, and atmospheric deposition and hydromodification. There are some economic aspects of pollution control that work quite well. Incentive methods that give economic rewards for non-polluting activities provide an alternative to regulatory laws at the local, state, and federal levels. Incentives are better for pollutants from many sources and less costly than regulation. Performance incentives like taxes on non-point pollution sources, design incentives like subsidies on inputs and control technology, market-based approaches like trading and/or abatement allowances all work. Economic incentives are frequently used to control non-point source pollution. In the U.S., we happen to be the world's leading polluter in many respects. That said, water and air pollution have improved considerably since the early 1970s due to more stringent regulation on all levels. An annual review of toxic pollution in the U.S. is provided by the Toxic Release Inventory that you can go see at this website. The TRI data have proven very useful in tracking the flow of toxics in the United States. Many environmental and community groups have used TRI data to place pressure on local industries to reduce pollution. Here are the major types of activities that cause pollution in the U.S. Metal mining, which we talked about with the tailings and the drainage and the heavy metal pollution. Electric utilities, primarily through carbon waste. More metals here, and then chemicals are the major. Here's one that affects us, the paper industry. And agriculture is also a major polluter in the U.S. Here are some changes in the release of toxic substances between 1998 and 2003. If you look at these areas, these are improvements in all areas. Disposal and other releases of toxic substances is down. Total air emissions, down. On-site surface water discharges, down. On-site underground injection, down. On-site land releases, down. So incentives seem to be working. In this section, we should be able to describe pollutant outputs. Also describe the myths of pollution control. How have rights-based control, cost-benefit analysis, and technology affected pollution control? What are some of the issues with these approaches? What is the contingent valuation method versus basic benefit cost analysis? Input versus output controls for pollution. What are they, and which ones work better? What are the legal milestones for pollution control, and what is the toxic release inventory and the major types of releases in the U.S.?